All right, ladies and gentlemen, we are going to be working on the CO6 material today. We're going to be working with specifically lines and transversals through lines that will create a number of different angles that we can manipulate and use to our advantage. So one of the things that we need to look at is what a transversal is. So I have posted this definition and theorem key, which has been updated since the last time you did. So if you haven't already, you'll need to pause the video and make sure that you get all of these vocab words completed and updated in your copy of your definition and theorem sheet, so that you know exactly what I'm talking about when I'm asking you or when I'm using the vocabulary for this section. So transversal is going to be the big thing that we're going to be using, and that is a line that intersects two other lines at two distinct points. So we'll take a look at what that looks like. And we are going to be on page 3 of our packet. The first thing that we're going to do, we're going to hold off on summarizing, filling in this blank, but I want to take a look at what corresponding angles are. And if you look at the definition for corresponding angles in our definition and theorem sheet, you see that they are the angles that lie on the same side of the transversal in corresponding areas. So if I look at my note sheet, I want the same side of the transversal. So if I look at these, I have two lines here, A and B, that are cut by this transversal. They're intersected at two distinct points by this transversal line T. And I want two angles that are going to be on the same side of that transversal in the same spot. So right here I have angle, well, let me get myself something other than white to write in, so that's not showing up very well. So I have angle 6 and angle 2 that are going to be on the same side of T in corresponding spots. So angle 2 is on the top right of its group, and angle 6 is at the top right of its group. So those are corresponding angles. Alternate interior angles, let me go ahead and use a different color. Let's use some purple here. Alternate interior angles are going to be like angle 3 and angle 6. So those are on alternating sides of the transversal, but inside the two lines. Alternate exterior, let's do those in yellow. Alternate exterior would be, for example, angle 1 and angle 8. They're again on alternating sides of the transversal. One's on the left side and one's on the right, but they are exterior to our two lines. And then same side interior angles. Same side interior angles are going to be like 4 and 6. So angle 4 and angle 6 are on the same side of that transversal, the right side, and they are also in between or on the inside interior of those two lines. So same side interior. Now I have, my next one is going to be vertical angles. And the example that I gave here was angle 3 and angle 2. So let me grab another color. I'm running out of colors here. So here for angle 3 and angle 2, I'm going to do that in the light blue. Angle 3 and angle 2. Those are those scissor angles, like I like to call them, because they are opposite of each other. And if you can imagine a pair of scissors, that would be the same thing as where the handle is and the blades are. If I open and close the scissors, the handles and the blades are going to open at the same angle from each other. So angle 2 and angle 3 are vertical angles, is what they're properly called. And then linear pairs are going to be just like 7 and 8. Do I have one more color? One more color is pink. Saving the best for last. So 7 and 8 are going to be a linear pair because they form a line. If I look at this line right here, that 7 and 8 are forming. So that is, in a nutshell, all of the angles that are created by this one transversal that is going through or cutting through these two lines. And these can be really helpful. Now, I didn't highlight all of my available options for corresponding angles. I didn't highlight all of my options for alternate interiors. So angle 2 and angle 6 are not the only corresponding angles in this picture. I thought that the picture was going to be cluttered enough without doing every single possible option, but 2 and 6 are an example of corresponding angles. So angle 2 and angle 6. And then the same thing goes for all of the other angles. These aren't the only ones that I could have given you, but they are examples of those. So let's go ahead and move on to the next section. We're going to want to make sure that we keep referencing back to those examples that we gave if we are stuck in what vocabulary we're talking about. So construct any two intersecting lines and measure their vertical angles with a protractor. So here I have a couple of intersecting lines, and you can just use a straight edge to create those. And I want to measure their vertical angles with a protractor. So I went ahead and I did that on my own examples, not necessarily the one that I have here. And I found that my angles are going to be 40 and 40 on the two sides of my, on the two side angles here. So those are going to be two of my vertical angles. And then if I measured these two, I'd also get 140 for both the top and the bottom. That tells me by demonstration, not really by proof, but I demonstrated here that vertical angles are always going to be congruent. So then the next step asks us to construct parallel lines and a transversal through the two parallel lines. If you need to remind yourself how to construct parallel lines, I have linked a math open reference, just like those construction animation links we were using before, that will help us remember how to do the parallel lines using a angle copying method. So that's there, and that will be posted in the description along with the definition and theorem key as well. So I'm going to go ahead and give you guys a second. You should pause the video and create those parallel lines using your compass and your straight edge. So once you get done with your constructions, your page should look something like this. And I need to follow the directions down, well, up here rather. Construct a parallel line through, I think I deleted the instructions for this. Well, what we're wanting to do here is to try to see how to fill in these statements. If two lines are what, then corresponding angles are what. So let's look at our corresponding angle postulate. So corresponding angles are going to be the ones marked here in blue. Let me go ahead and use my own marks instead of the construction marks so we don't get confused. So these two are going to be an example of corresponding angles. And from the construction that I have on my paper, again, not necessarily the picture that I put here for this video, but the one that I did on my paper, the two angles in that position had a measure of 70 degrees. So for those two corresponding angles, I found that they were congruent. That only is true if I know that my two lines are parallel, which is what we constructed these two lines to be. So for the next question, alternate interior angles, I need to find a set of alternate interior angles. I want to check to see whether those angles are going to be congruent or supplementary. And then I want to do that for each of these next couple of problems here. I'm going to ask you to pause the video and try these on your own, and then we will discuss. And with a little media magic, I end up having my solutions. Now I separated mine. I know you can't necessarily do this with your paper constructions, but just to make sure that it was getting a little messy to try to get all of this on one digital copy. So I separated the picture that I have here for corresponding angles. I made one for alternate interior angles, one for same side, and one for alternate exterior. So looking again at the corresponding angles, these top right angles here for our corresponding angles, they were both 70. We said that that meant that they were going to be congruent. So making these lines parallel made these two angles congruent. Looking at my alternate interior angles, alternating sides of my transversal inside my two angles, alternate interior, I get 110 degrees for one and 110 degrees for the other. I'm really quite sure why that turned green. So 110 for both angles for my alternate interior. So alternate exterior, again, alternating sides of my transversal, outside or exterior my exterior of my two parallel lines. These measured on paper 110 degrees. And then when looking at my same side interior, I'm again, same side of the transversal this time. So these were both to the right of the transversal. And inside the two parallel lines, so interior, same side interior angles, these are going to be 110 for this one and 70 for this one. So these are not the same anymore. If I add these up, I actually get 180 degrees, which would make them supplementary. So filling in the blanks down on these lines, if two lines are parallel, then the corresponding angles are congruent. If two lines are parallel, then alternate interior angles are congruent. If two lines are parallel, then alternate exterior angles are congruent. And if two lines are parallel, then same side interior angles are supplementary. That one throws everybody for a loop. So we're going to go ahead and take a look at another application. So not only once I know that the lines are parallel, I know that these are going to always hold true. So once I know that the lines are parallel, I know that alternate interior angles have to be congruent, so on and so forth. The same can be said in the reverse. So the converse is basically the reverse of everything that we just did. So these ones started with parallel lines. That's the first thing that we did, was construct those parallel lines. And then we ended up finding our angles either congruent or supplementary. The converse of that is to start with your angles congruent or supplementary and finish or end with the lines being parallel. So if I know that alternate interior angles are congruent, then I know that the two lines are parallel. And that's what that theorem is saying. So for question number 1, they want me to provide appropriate marks to show that angle 1 and angle 4 are congruent. Now let me grab a pen tool. I'm going to draw one arc at 1, angle 1, and a single arc at angle 4 to match. That notation shows that angle 1 and angle 4 are congruent. If they are congruent, this question too is asking me which lines would be parallel. Well, here's what I like to do. I like to cover up anything that I am not using. Let's get that to be much larger. So undo that one. I'll do my best to cover that up. Okay, so all of this stuff over here in this image is kind of nonsense for the question that I'm being asked. I don't need any of this stuff over here. So I just did my best to try to cover it up there and just really focus on what I have over here that involves these two pink arcs. Come on, go away. Okay, so the two lines that I would say are parallel, if those two pink arcs are true, if I do actually have those congruent angles, the lines that I would say are parallel are lines L and M. So line L with a line over top is parallel to line M with the arrow on top. Okay, and that's it for questions 1 and 2 here. I want you guys to go ahead and pause the video and try questions 3 through 6 on your own, and then we'll go ahead and go over the solutions for those. So for alternate exterior angles, if alternate exterior angles are congruent, then I also know that the two lines are parallel. So to show the markings for 3 and 8, I can do, let's do 2 this time. If I do 2 arcs here at 3, then I would have to do 2 arcs here at 8. So if I have 2 here and 2 here, those 2 arcs rather, show that 3 and 8 are going to be congruent. If 3 and 8 are congruent, which 2 lines would be parallel? Well, I can do that trick with covering up what I don't need. So I don't have any marks that involve B at all, so I'm going to go ahead and put something over here to kind of block that. And now it helps my eyes to focus when I do that, because now I can see a little bit clearer that the lines that would be parallel if 3 and 8 are congruent would be L and M. So the same ones as the last question. Using my proper notation to say line L is parallel to line M. The next converse that we're going to look at is that if same-side interior angles are supplementary, not congruent, same-side interior are supplementary, then the two lines would be parallel. So I'm going to use my diagram to label 5 and 6 as supplementary. So here I actually want to do 1 arc for 5 and 2 arcs for 6. Since they're not going to be congruent this time, I don't want to have the same number of arcs for 5 and 6. If those two are supplementary, which two are parallel, well, I can cover up what I don't need down here and just focus on what I have up here. Well, the two lines that I have up here that would be parallel would be A and B. So I have line A is parallel to line B. When two lines are cut by a transversal, if corresponding angles are congruent, then the two lines are parallel. So I can say they want me to provide markings to show that 1 and 2 are congruent. So 1 and 2. So which two lines would be parallel? I'm going to go ahead and grab something to cover up what I do not need. So the two things that are going to be parallel, I still need to know what the names of these are, so I'm going to move this just a bit. I need the names of the lines up here. The two lines that would be parallel, if those two pink arcs are true, if those angles are congruent, would be A and B. So when you are completing these on your own, make sure you mark what's congruent first. Actually do the markings here first and then cover up what you don't need. It'll be a lot easier for you guys to cover up. Just use the corner of a sheet of paper or a sticky note or something to cover up what you don't need, because then it makes it really clear here which two lines I only have 2 lines left that could be parallel, and that just helps my eyes focus rather than looking at the whole picture itself. So now we're going to go back to page 3 and summarize everything that we've done in, well, it'd actually be 6 tidy little theorems instead of having to remember all of the theorems and their converses, because what I have not done actually so far, and I need to do it right here, is they asked me to justify my answers here for my parallel lines. So I'm going to go ahead and do that real quick. So here, my justification for L and M being parallel would be converse to the alternate interior angle theorem. Because I used the one where we started with the angles and ended with the parallel lines. They gave me the angles and I ended with the parallel lines. Here, I would have the converse to the alternate exterior angle. Again, starting with the angles, ending with the parallel lines tells me I'm using these converses. So this one is going to be the converse to the same side interior angles theorem. And then for this one, again, starting with the angles, ending with the parallel lines tells me I'm using the, well, this should be the corresponding, oh, no. This one is the converse to the corresponding angle theorem. Now, if we use these as is, we will have to forever remember which way was which. Which one was the converse? Did the converse start with the parallel lines or did the converse start with the angles? We can see here that the converse starts with the angles, but it's really hard. It's very easy to make a mistake when we do this as a theorem and its converse. But on page 3, I have a nice, neat, little, tidy way to kind of clean up everything that we just did. And that is to use this, and it's not an error in my typing. It's an if and only if statement. And I can combine those theorems and their converses into one nice, neat little package so that no matter what I'm doing, I can just quote these original theorems and postulates. So let's go ahead and fill in my answers here. For the corresponding angle postulate, 2 lines are parallel if and only if corresponding angles are congruent. Alternate interior angle theorem. 2 lines are parallel if and only if alternate interior angles are congruent. Alternate exteriors would need to be congruent as well. And same side interior, that's our oddball, that's going to be supplementary instead. That means add to 180. Just like the 70 and 110 that I had earlier. And then for vertical angles we get that they are congruent. Vertical angles are going to be congruent. And notice I don't have anything about whether I have parallel lines here for vertical angles. the statement is that vertical angles are congruent, period. It doesn't matter what I do to the vertical angles, they are going to be congruent, period. There's no conditions. It's just always going to be that way. The same thing for my linear pairs. So just like the pairs 7 and 8 up here, these are always going to be supplementary. If you notice, I only have two options for my angles. They're either going to be congruent or supplementary, and that's it. I'm either going to have them adding up to 180 degrees or they're going to be exactly the same. And that's going to work for all of these angles as long as I have parallel lines. That is so important that for these top four postulates and theorems here, those lines have to be parallel. So I have to either have them marked as parallel, which these A and B clearly are not, but I can mark them as parallel using two little arrows on both lines to show that they are parallel. And then once I know that those are parallel, then all of these four fall into place. These two will work. It does not matter. I do not need parallel lines for these bottom two. All right. So that is the explanation for what our 6 common angles are using transversals. And we are going to get practice tomorrow on what do we do with all of these. But I'm going to end this video here so that you guys can kind of digest what just happened. Make sure your definition and theorem sheet is up to date because that has a lot of new things on it. It has all of the, I didn't include the converses. Let me actually make one thing clear here. Now that we have summarized all of those theorems into if and only if statements, I get to just say that this is the corresponding angle theorem for here. Same side interior angle theorem. Here, alternate exterior angle theorem. Because now that I have these as if and only if statements, I don't have to worry about which one's the converse and which one's the original. So that was the whole point of writing them as if and only if statements, is that that part was made even just a little bit slightly easier for us. But we're going to get more practice with all of these this multitude of information here in the next video.